I want to welcome every one of you to ArmanisMath. Today we're going to focus on number sets and notations. Here's the warm-up, and I'll give you about a minute for this warm-up. It doesn't require that long. Today we're going to write a lot of notes, so make sure that you're ready with your notes. I do ask for notes to be uploaded, so make sure that you have them nice and neat. Right? You've got to do the warm-up. That's what helps us get our minds in the game and gets us ready for the lesson. Okay, starting with the first one. Write the following in a decimal format. Can you use the chat? You got both chats, YouTube Live and also the other chat. Give me some answers to these questions here. Right, thank you. That is actually 2.5. Right. And use words to describe this. Well, the answers might vary, obviously, but it would be something perhaps like store hours, or we're open from 9 to 5, from 2, starting from 9, ending at 5 p.m. 9 a.m., 5 p.m. The third one is graphing or plotting x equals 3. I'm going to spend a couple minutes here. X equals 3. Equals 3 means I go to the 3 and I circle the 3. Not just that, because it's equal to, I have to include the 3. 3 needs to be included, so I have to bubble in. Bubble. Can you say with me? Bubble in the 3. Fill it in. And then you stop there, because x is equal to 3. That's the value that you include. Let me spend a couple more minutes here. So what have I said? Plot x is greater than 2. Well, I'm going to go here. I'm going to label -2, 0, 2, and I will go to the 2 and look. Do I have equal to? No, you don't, Armani. It just says greater than. Okay, so I'm gonna go here, and then greater than, it's gonna be this way. Remember that the number line is what has an array that goes to infinity, so it could be 3, 4, 5, 10, 100 million, trillion, whatever, all the way to infinity and beyond. Buzz Lightyear, infinity. You just keep going. All right, what if I said we needed to do x is less than or equal to 4? Okay, so use a number line, and we're gonna go to remember this arrows here, arrows. I gotta go to -4, 0, 4, and then I gotta have myself a circle, and in this case I have to bubble the 4. Sure, fill in that bubble. And then where are you going, Armani? Well, you're saying x is less than. It's less than 4. So you're going this way. I'm going to go this way. Like this. All the way to that direction. Which means I'm actually, if you want to really think about this is going to all the way to negative infinity. So negative infinity is the beginning point, which is not a point. It's not a beginning, because there is no beginning in infinity. But you're going to start from negative infinity. And there's no way for me to hug infinity, so I'm just going to start somewhere here, all the way to 4. I'm going to stop exactly at 4. And I will include the 4 because it has an equal sign. Last but not least is going to be, what if they ask for something like this? The x is between, let's say 2, and it's greater than, let's say -1. Okay, sure, no problem. So I'm here, and I am on the number line. Again, number line extends to negative infinity, positive infinity, infinity plus negative infinity. Ha ha ha. Uh-oh. Okay, and I come to 0, and I've got -1, and here is 2. So how do I represent that? Well, come on, Armani. You could make yourself a circle. Sure. Add another circle. Sure. What do I do with the -1? Do I bubble or not bubble? Armani, whenever you see an equal sign, you bubble. Sure. Okay, I'm gonna bubble. And I'm between this x, this variable, the value that I'm looking for is in between -1 and 2. Okay. Do I include 2? No, you don't, because you're less than 2. So how close am I to the 2? Well, we do not know. Could it be 1.99? Sure. Could it be 1.9999? Sure. As long as you don't touch 2, you're good. Okay? So you're good with that one. All right. His objective today. Student will be able to use basic concepts in algebra to solve interval and inequality problems. Okay, that was too fast. Give me one word from the objective in the chat, please. Choose a word and put that in the chat. Choose a word and put that in the chat, please. All right, here we go. Thank you. Where in the whole world do we use this kind of stuff? Well, one of which is actually your AC thermometer. So in the AC thermometer, you set this to an interval, to an inequality. For example, I want the temperature to stay below 78. Okay, so my temperature has to be less than or equal to 78. Anytime the thermostat feels it's 78, because it's equal to here, this is gonna start. The AC is gonna start working. Vroom, 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 whatever chugging it does. Hopefully it's gonna keep up with the heat wave that we have here. Thank God it has been. But anyways, so less than 78. You wanted it to be less than 78, and that's why you set your thermostat. But also, if you really want to be careful, you do not want it to freeze in the house, right? So in the place that you live at. So you also want it maybe to be above a certain, maybe 68 is the coolest that you could handle. So your thermostat is going to be toggling between two values. It has to keep you below 78. At the same time, it's going to give you enough, I guess, heat or warmth in the house or the place where you're going to be above 68. Otherwise, you'll be freezing. All right, so this is actually an inequality. Can you think of another example? If you can, put that in the chat. Or you could Google and then tell us what you got afterwards. There is a good number of definitions here, which we are going to touch on very briefly. Okay, because each one of these will be defined later on in today's lecture. The first one is a set. So a set is a group of things, obviously. For example, let's say a set of freshmen, a set of seniors, something like that, okay? First year college students or something. So a set is a group of things, grouping that you are putting things together in. And So let me actually give you a very like simple example. A set would be something like let's say that you closet, okay? You have a set of your clothing, set of clothing. So you look at your closet, big and huge, like this, for example, okay? And in the closet, you have drawers or shelves. So here's a shelf, here's another one, here's a third one, okay. So the first one, let's say that you have your shirts, and that's where you keep your shirts. The yellow, the blue, the navy blue. The second one is your pants. And the third one is your socks. Okay? So let's say that the set now is the whole thing. It's a set of your clothing. Every set has elements, and every set could have subsets. For example, a subset of your clothing would be the subset of the shirts, another subset of the pants, another subset of the socks. Okay? Simple? Now every subset or every set would have elements, items in it. So for example, if I'm looking at my shirts shelf, which is, remember, a subset of the clothing set, it's a subset, then maybe I could have something like the blue shirt, the pink shirt, blue, pink, the red shirt, okay, etc., etc. So that's every one of these shirts are going to be an element in that subset. Could it ever happen that you end up with an empty set? Yeah. I mean, hopefully you're doing some laundry with your parent, or you're doing the laundry yourself. So I look at my socks drawer and there's nothing. What? Yeah. I guess I gotta help in laundry, I guess. So anyways, so if you have nothing, you have in math something called empty set, and there's a symbol for that. We use a phi. So it's a circle and a line through it. We call this as a phi. It's a Greek letter, just like theta. Remember theta? This one is a phi, and it denotes an empty set, blank. There's nothing there. All right. Next one is the roster notation. So roster notation means like exactly like my roster, which has every single one of my students, and everyone has an ID, and everyone has a lot of data. Okay, so my roster is very detailed. It's listing every single one. Okay, this is roster. So obviously you can't just use roster notation for everything that you want to list, because it's gonna be cumbersome. For example, I cannot use roster to list all, let's say, all students in the world. I can't use roster for that. That's going to take me nights and days, and that's not going to be possible. That's why you do not use roster notation for anything. You use it for certain things, right? Not just for anything, but use it for certain things. It's probably beneficial to use it when you have a finite set, things that you can count, and there are not too many of them. Okay, for example, I could have a roster of my own students, right? Like let's say a total of whatever I get is, let's say, 150. So every class, let's say we've got 40, right? So there's a roster of that, which is kind of doable. Not what I like, but that's doable. But you cannot use a roster notation, for example, for something that is infinite. Infinite? That's too many of them. Here's an example of infinite. Here's an example of that. For example, what if I said, can you list all odd numbers? Okay. So you can list, for example, 1, 3, 5, 7, all the way through infinity, right? Yeah. So that's going to be the infinite set, which you do not use roster notation for. Usually you don't choose that route. You choose something else, like the set builder notation. Ooh, what a fancy word. You choose the set builder notation for that purpose. You say, for example, X, which is the number that you're looking for, such that x belongs to odd numbers, for example. Odd numbers. More on this to come, by the way. It's just brief definition. Okay? So that way you started the set with curly bracket, you finish with curly bracket, and then you use a kind of a bigger umbrella to capture all these items without you listing every single one of the infinite. Impossible to count. Too many. All right? So that's the set builder notation. Last but not least is something called the interval notation. So in math, you could use something called interval notation. And for interval notation, you have basically two end points. You have this symbol here, brackets, starting and ending. Or you also could use parentheses, starting and ending parentheses for this interval notation. All of which we're going to talk about in details, okay? It's just a heads up of things to come. All right. Here's our first example. It says raster notation is not suitable to represent infinite sets. Well, we just talked about that momentarily, right? You can't use that for anything you like. For example, all real numbers between 5 and 7. Well, Armani, excuse me? Between 5 and 7, there's only one number. Okay, let's take a look. Between 5 and 7 is 5. And here's 7. There's only one number. That is not true. Because, yes, I know there's 6 here. But is there also 5.1? Yes, there is 5.1. Between 5 and 7, there is 5.1. What are 5.001? Like here. 5.01. Or what if something that is actually less than that, 5.000001? Yes, of course, that lives here as well. That's why you do not use raster notation for infinite sets. You don't use that. So what can you use? Well, there's two other ways that you could represent. I've used a total of 4 different methods today. But there's 2 other ways on this to begin with to represent numbers between 3 and 5, for example. You could use the number line that we've did just a minute ago. You also could use the inequality. So there's 2 ways to do it. You cannot use raster here. It's not gonna help you. So let's use the number line. Number line between 3 and 5. Number line. So I have 3, got 5, and we just talked about number line between 3 and 5. So that doesn't say including 3 and 5. That's why I leave that thing open. And the second is inequality. How do I put this in inequality? Well, your number, which is x, is going to be greater than 3, and it's less than 5. Because you just said it's between 3 and 5. You didn't tell me it's including 3 and 5. You just said between 3 and 5. So that's another way to represent the information, okay? Between 2 numbers. Not raster. Or between 2 and 4. Just like that. Inequality and also number line. Okay, how do you use interval notation? Well, here is a good example. It says interval notation defines all sets of numbers between 2 end points. For example, if you wanted the numbers between 1 and 7 and you want to use interval notation, you could use the brackets and parentheses with one little exception. If you want to use the bracket, this really have to make sure that you really include the value. So maybe on top of the bracket, when you take notes right now, you're going to put the word equal to. The symbol, I should say, equal to. If you want to use the bracket, you're going to have to be saying or meaning that you want to equal to. You want to include that amount. Okay? So if that's what you want, then you could use the bracket. If not, then you use parentheses. Parentheses says you are excluding this end point. It's not part of your solution. Let's take an example. For example, I have here a number line from 1 to 7. And I have a circle, if you can't see it, I have a circle, open circle here, and I have an open circle here. Okay, and with all numbers in between. I did not include the 1, I did not include the 7. Hence, when you put this in an equality, you are greater than 1 and you are less than 7. There's no equal to here. So how do you put this in an interval notation? Remember, interval notation, you're going to be using what? Brackets and parentheses. So I could use my interval notation by doing the following. And let me change the thickness here. That's more thicker. I'm going to use a bracket. No, I can't use a bracket. Why? Because it's not equal to. You're not including this one. If this bubbled, yes, but it's not bubbled. So the other option I have is parentheses. So I'm going to use parentheses, and then you usually start with the least, the lowest point, and then go all the way to the highest point, and then use parentheses again. Why parentheses, Armani? Well, look, the circle's open. If the circle's bubbled, I will use bracket, which means in this case this has to be equal to, right? But it's not. So I'm not going to use that. I'm just going to use the what? The parentheses. I cannot use the bracket. Okay? So here's the interval notation. Parentheses is used. Just a side note here. I know maybe some of us would feel kind of, I wouldn't say betrayed, but baffled. How come we use this here, parentheses, for interval notation? I thought we used them for something else, Armani. You actually do. We use this parentheses when we graph on the Cartesian coordinates, or the x and y coordinates, remember? So we use them like it's 1, 2, 3, 4, 5, 6, 7, and then you say parentheses 1,7, right? But also remember that these are not the same. This is different concept. This is not the same. This is the x and y plane, right? It's not the same as interval. Meaning, in the x and y plane, you're talking about two separate things, two variables, the x and the y. However, in the interval notation, you're only using one variable. You're saying this value or the variable, for example, x, is between this and that. And please do not confuse both of them because these are not the same, okay? One of them is only as one variable that you're using, one variable only, and you're saying it's from 2. The other one is x and y plotting of the point. It just happens to use the same symbols, which is parentheses. Another quick hint here on this cute slide is the idea of the infinity. Infinity and beyond, Buzz Lightyear. What's the idea of infinity? Well, if you want to use the interval notation for infinity, you've got to use parentheses. Why? Well, because you cannot contain infinity. There's no way for me to say, I know infinity, and I'm going to put bracket because it's equal to infinity. No, I'm sorry, there is no equal to infinity. Infinity is not a number to hug. It's too big of a number to hug. I can't put my arms around infinity. Come on. You can't put a bracket for infinity. That's why you put parentheses, meaning up to that, close to that, but not it. And obviously I cannot touch infinity. That's why we use parentheses for infinity. Okay, I've talked a lot, so now let's recap. So I'm gonna use my curtain and close the curtain, Armani, and make the curtain hide some stuff. One thing at a time, okay? Let's look at the first thing on my list. On my list, let's say that I want, here's 4 different ways to represent things in math, or represent numbers or sets. First one is the words. Oh, words are powerful. Make sure you use them wisely. Okay, so for example, in words I could say numbers less than 3. Okay, thank you. Less than 3. It doesn't say equal to 3, by the way. It just says less than 3. So how do you put that in a number line? We just looked at an example like that earlier where you circle the number that you want. And if you're less than, obviously you're going to the left, right? Less than that number. The circle is open because it says less than, it doesn't say equal to. How do you put that in equality? Well, you start with equality, remember, with you'll start reading the inequality from the variable, so x is less than 3. That's how you put that in equality. So I started the words, and then the number line, and then the equality, and then finally the interval notation. Since you are not including, you're not including the 3 because it says less than 3. What is less than 3? Well, 0 is, -1 is, -100, all the way to -infinity this way. So you're going to go through my screen. Look at this. Oh, go through your screen. Oh, go through the walls, whatever you're at right now. You're going to go all the way. So that's why the least number that you could start with the interval is going to be the -infinity. Remember, you cannot have a bracket for infinity. So I have -infinity, comma, it means all the way to 3. Do I include the 3? Well, Armani, you've got to have to look. Do we have an equal sign here? No, I don't. Then you do not include it. Does it have a bubble here? No, it doesn't. Then you do not include it. Okay, does the word say equal to? No, it doesn't. Then you do not include it. And you do not include in interval notation, you do not include the value when you have parentheses. All right, that's the first one. Second one. Numbers greater than or equal to. Ding, 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 ding. I have a flag on my brain. Equal to. Okay. To -3. So I come to -3. It's the number line here. I put my circle and I really have to bubble. Bubble, bubble, bubble. The circle. And then I'm moving to the right because it says greater than. So I'm going to move to the right. -1 is obviously is bigger than -2. 0 is bigger than -1, etc., 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 all the way through infinity and beyond Buzz Lightyear. Okay, so this was the number line representation. What about the inequality? Well, x, whatever the number you're looking for, the value, is greater than negative or equal to -2. Or equal to. Don't forget that word, equal to. So when you come to the interval notation, you've got to use that bracket. It's bracket because you're saying it's included. -2 is the least amount that you start with, going all the way to infinity. Okay, cannot touch infinity. So that's why I use parentheses for that one as well. All right, and let's see number 3 here. The third one here. Numbers between 2 and 4. Okay, so here is 2. I have an open circle. 4, I have an open circle. And numbers between them, not including the 2 and 4, by the way. So x is between 2 and 4. It's greater than 2, less than 4. How do you put that in an interval notation? Well, you did not include the 2, Armani, so you have to put parentheses. Parentheses, 2, right? Parentheses, 2. Comma, all the way to 4, not including the 4. All right. Last but not least is 1 through 3. So if I told you to count 1 through 3, what are you going to do? You're going to say 1, 2, 3. Okay, which means this implies you have an equal to. You have to include the 1 and the 3. And that's why when you go to the number line, you include it. And you include the 3. Everything between 1 and 3, including the 1 and the 3. Which, when you come to an equality, how do you include an inequality? You put an equal sign. So it's including 1. Up to 3, including 3. That's why you use the equal sign. How do you put this in interval notation? Well, anytime you have equals to, you put bracket. So bracket, 1, 3, bracket. Okay? Because you are including these two values. Hopefully that was helpful. In your chat, please, are we doing good here or should we review more? In your chat, please. Choose either chat to tell me your feedback. Choose either chats to tell me your feedback. All right. Okay, good. So let's go on. Use interval notation to represent the set of numbers. Remember, you're talking about set, a collection of numbers. So how do I use the interval notation for this one? Okay, let me think. You gotta think in math. Okay, interval notation. I remember interval notation deals with brackets and parentheses. Interval notation has brackets or parentheses. So I'm going to keep that in my mind. So let me take a look here. It says x is greater than 7. Does that include 7? No, it doesn't. Okay. So if I want to put this one interval notation, I will have to use brackets and parentheses. So I could say it's not including the 7. That's my end point, the lowest end point, the least, all the way to 12, but I have to read it carefully because it says you could be less than or equal to 12. Okay, that means I really have to have a bracket here. Okay, this is for interval notation. I always wanted you to go the extra mile. Always go the extra mile, okay? If you're doing average, even in the future on the job or anything, you're just going to be average. Don't just do what you're asked to do. Go a little bit further. Go the extra mile. So, yes, they only asked me to do interval notation, but I'm going to do one more thing, which is the number line. So I'm going to put down a number line. They didn't ask for this. I know they didn't. But I am the one who goes extra mile. So here's my number line. How do I represent this in the number line? Well, you have 0, and obviously it's not drawn to scale here, but you have 7, and I have 12. And I will make a circle, and I really have to think, okay, hold on, Armani, this one is open. Yeah, because I'm not including 7. I'm less than 7. So I'm good. This one is closed or open. Well, let's read. It's less than or equal to. And look at the interval notation. It's including the 12. Oh, okay. Which means I really have to go here and bubble, 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 bubble until the cows come home. Okay, and then I would connect them just like that. So I went the extra mile to, just for me, by the way. It's not to show anybody. It's for me because I'm practicing. This is me practicing. This is me learning, not just do it for somebody else. So I would go the extra mile. How about this dude here? Use the interval notation to represent the set of numbers. Okay. Looks like I've got 2 of them here. All right. Let me focus on one of them at a time. Let me see. My. I'm going to focus on this first. So I am in between -6 and -4. But I also have to pay attention because the circles are filled in. They're bubbled. Filled in. So this means I really have to include the -6 and include the -4. Okay. How about the other one? Well, this one looks like I'm looking at a 5 or something, right? I'm looking at 5. So this is 4. And then there's something here. Oh, okay. That looks like a 5. So I'm going to put 5 here. At 5, I have an open circle, which means I'm not including the 5. And I'm going all the way to going to the 6 and through the 6 and the 7 and all the way through infinity. Infinity. Okay. How would I write this in interval notation? Well, do I use parentheses or brackets? In your chat, please. Do I use parentheses or brackets for this? Yes, you've got to use brackets because you're saying you're including the value. So here's a bracket. And I put -6 because that's the least end point, that's the lowest, and then all the way to -4, which also has to have a bracket because it's bubbled in, it's equal to. Or the other part. Now the other part looks interesting because I have an open circle. That means I have to have parentheses. And then the 5 all the way through. It looks like I can't stop at 6 because that thing keeps going and going and going and going to infinity and beyond. So it goes all the way to positive infinity, and as I said, we cannot hug infinity, so we have to use parentheses for that one. This was the number line. Number line. This one here is actually the interval. And this last one, they didn't ask for it, but Armani likes to go the extra mile always. So this one is going to be inequality. So how do I put this one in equality? Well, let's take a look. You are in between these two numbers. So the x is, and for this one I really have to separate them, okay? You have to have two different inequalities here, just for sanity check. So let's just do that. So your x is between two numbers. Your variable x is between two numbers. You are greater than -6, including -6. Let me do a different color for this dude here. Including -6. Including. And you are between two values here. -6 and -4. That's the first one, inequality here. This dude here is kind of similar, but not that similar. X is greater than 5. That's it. I don't put equal to because it's not included. Okay? Right, champions. All right. Let's keep going. Set builder notation. How do you deal with set builder notation? It uses set builder notation. Sometimes, by the way, it's only abbreviated as set notation. You could also use that word, set notation, instead of set builder notation. It uses the properties of the elements in the set to define the set. Inequalities and elements, element symbol, this symbol here, which is like an inverted E, like the euro symbol, are often used in the set builder notation. The set of striped, for example, the set of striped billiard balls numbers, or 9, 10, 11, 12, 13, 14, and 15, is represented in a set builder notation of the following. So here's an example of a set builder notation. How does it look like? Looks like this. For example, the set, like the number x, is such that, and that vertical line, by the way, that vertical line is the same line that's used for email. Remember that email that you sent me? So I would call this such that. So x, you always start with the bracket, so it's just one thing at a time. Bracket, curly bracket, and then you put the variable x such that, that's the vertical line, and then you put the statement for the x. Where is the x? X is greater than 8, negative or equal to 15, and x, whatever that you're looking for, belongs to or is part of that inverted E symbol of the n. And I really have to be interested in, I really have to be careful, because this is not just a regular n. Look at this n, it's kind of a double-chinned n. So it's like this. Okay, and we use this in math to refer to the natural numbers. Natural numbers is a set of numbers. So just like your closet and your clothing in the closet, where you have sets, same thing with numbers. Numbers are not just numbers. Come on. Numbers are defined in their own sets. For example, the set of even numbers, the set of odd numbers, and there are some other sets. One of which here is called the n. The big N is the natural numbers. Natural numbers is what you teach your little sibling. Can you repeat after me? Count 1, 2, 3, 4. Okay, and that's the natural numbers. That's what comes natural to us. How do you read this? Well, you could read the above as this: the set of all numbers x such that x is greater than 8 and less than or equal to 15 and is a natural number. Is a, or part of, is on this inverted E here. Is a, or part of. That's the symbol that we use in math. Here we go. This symbol is an element of. So you could say, so x is an element of n, and we could read this as x is an element of the set of natural numbers, or x, basically you just could not say the word element of, you could just say x is a natural number, just to abbreviate. We call this a set builder notation. Set notation. Okay, both mean the same thing. All right, I'm going to use my curtain here again, and let's see if we could hide some stuff here, one thing at a time. Okay, so methods of set notations. It says here, for example, in words, roster notation, interval notation, and then set builder notation, or sometimes we just say set notation. Okay, so first of all, let's take an example. It says all real numbers except one. Okay, all numbers except one. It's really hard to put that in a roster. I mean, do you want to put 0, -1, -2? Do you want to put 5, 100, 1 million? There's too many to number here. That's why roster notation is not used for things that are too big to count, or it's infinite number of things here. It's cumbersome and too. So we're not, in this case, we're not going to use roster notation. That's not going to help us in our case here. Okay, that's not going to be used. But we could use interval. Interval for this guy, it says all numbers or real numbers except one. That means I could go all the way from infinity to infinity, and not including one. So I'm going to go here from infinity to infinity. So this is 1. Let's say 0, for example, and this is 1. So I will go from, basically that's what you're saying, like here or here, but not the 1. So how do you put this one in interval notation? Well, you're saying you go from negative infinity all the way to 1, not including it, or 1 to infinity, not including either the 1 or the infinity. Okay, that was the interval notation. How do you put that in a set builder notation, or as we said sometimes, just set notation? You could use the curly bracket x such that that line is such that x does not equal to 1. What does not equal to 1? Or everything else. Could be 1.1, it could be 1.5, it could be 5, 16, 100, 1 trillion, whatever. Okay, let's take a look at the second line here. And this one says pause. For example, in words, can I, let me erase this here. So we're talking about the second element here, positive odd numbers. So I could list positive odd numbers in roster. Yeah, but again, you really gotta be clever. I mean, you really have to, kind of fool the system. So if I want to say odd numbers, it's going to be 1, positive odd numbers, 1, 3, 5, 7, and then I'm not going to keep counting until infinity. So I'm going to use dot, dot, dot. It's kind of a workaround. Not really recommended because you're saying roster. Roster means you need to include everything. So again, kind of shaky. Probably not for this case. Can I put this in interval notation? That's a tough one. Cannot put this one in interval notation either. No, that's a tough one. Because you really have to have, like, remember the interval notation, you have to have a bracket or parentheses. So what are you not including? What are you including? That's tough to put here. But what we can do for this case here is to use set builder notation. See? That's probably the most optimum for this case. X such as x equals 2n minus 1, which goes back to your previous math knowledge, and n, that number that you're looking for, belongs to the natural numbers. That's how we define positive odd numbers. Okay. Last case is going to be here. Last case is going to be this one here. Okay. So numbers within 2 and 3 units of 2. I'm sorry, numbers within 3 units of 2. So like you go this way from 2, 3 units, and then you come this from the other direction, is also 3 units from 2. So it says set roster. You cannot put that in roster. But interval notation, I believe you could. So why? Because let's say I'm a big fan of drawing stuff. So I'm gonna draw myself stuff like the number line. You said you are 2, and you're 3 units this way. 3, 4, 5. Okay, that's 5. And 3 units was 1, 2. So this will be a 1, 0, -1. So numbers, and this implies that you're including including the endpoints. So you're saying that this is included, this is including. So that's why you have a bracket, -1 all the way to 5 bracket. You also could use set builder notation for this one, x, such that x is between and in between -1, greater than or equal to -1, less than or equal to 5. So these are a couple of things that you could use for these different presentation. So I guess what we're trying to see from this particular slide is things would not really work all the time. It just depends on the case and the scenario. Some would make sense, others would not. Okay, before I go further into these, I'll need to just show you a couple things here. Okay, I'm going to show you this example here. This slide shows you a big umbrella of the numbers that we're using, or the number set. Okay, and for this one, I probably would like to use a graphing tool. So I'm gonna use a bigger, like for example, like this. Okay, bigger umbrella. Oh yeah, oh yeah, oh yeah. All the way down here, and down here. Okay. What are we doing here is classifying numbers. Classifying numbers in their sets. Remember, numbers have sets. And here is a bigger kind of umbrella that covers numbers. So in numbers, the first ones come to us to mind is the natural numbers, which is, remember you take your sibling, count after me, 1, 2, 3. So you start from 1, and then 2, and then you keep going. So when they reach 10, hey, bravo, good job. Now, you don't reveal the fact that there is a 0 in the thing, because when you start talking about 0, then that becomes another bigger category, which includes the natural, that also has 0. So 0, 1, 2, it's called the whole numbers. So the first one that we're accustomed to is natural, because that's what comes naturally to us, 1, 2, 3. And then the bigger is 0, including 0, that becomes the whole number. Now, what if you want to go to the left side of 0, like -1, and then 0, and then 1, etc., etc., etc.? So that's called these integers. And all of these, by the way, have their own label, symbols. So natural numbers have their n, but the double chin n, this guy here, see double chin n? That's the natural numbers. Whole numbers uses a w, double chin w, okay? And the integers are the z's, integers. Rational numbers are bigger, which means you could also include the decimals, right? Like the one that we had in the warm-up, 5 divided by 2. 5 divided by 2, or 2.5. Rational numbers also could include any fraction, but when you divide the fraction, you will have either terminating decimal or repeating decimal. So for example, a rational number could include 10 over 3. So it becomes 3.3 and 3 and 3 and 3. That's a rational number. Or also could include the 5 over 2, which is 2.5, and then you stop there. You don't move further. 2.5, and then you stop. That's a rational number. Okay? Irrational, oh, by the way, rational numbers have the Q's. This is CQ here, the double chain Q. Irrational numbers are almost like the Q's, the rational, but when you divide them, they do not stop. So, like for example, a square root of 2. That's not going to stop counting. It's not going to stop giving you decimals, and they do not look the same. It's not going to repeat it decimals, right? So it's going to keep on going and give you different decimal, different decimal, different decimals. That's why it's called irrational numbers, because they do not stop and they are not repeating. Either stop or repeating would be rational. It's irrational, doesn't make any sense because it does not stop or does not repeat. So there's always something new in irrational. It's just irrational. There's a symbol for irrational, which I actually had to look that up. That is the double chin Q, but with the prime, Q prime. There's a little apostrophe at the top here. All these guys are found in real numbers. Oh my gosh. All what we talked about are found in real numbers, and all real numbers are part of the complex numbers. Complex numbers. So the complex numbers are, if you guys remember the imaginary part, the eyes. Remember that? Hello, the eyes. The complex numbers covers the imaginary and the real. And that's why this is the setting for these. I know this is not gonna be your favorite, but just for you to know, just as you are making sets in your own clothing closet, for example, or your own books and supplies, we also have sets in numbers. Okay, here's an example on I'm sorry, also real numbers have the big double chin R, real numbers. So there's another slide here that gives you an example of all of these, and I'm just gonna add for the irrationals, or the Q's, double chin Q's with the prime. That's irrational. All right, I know there's too much here, but you guys could handle that. Okay, let's go back here a little bit and then talk about this example. This one says translating between methods of sets. Okay, let's play with that. It says rewrite each set in the indicated notation. For example, they given me this set here in letter A. Excuse me. They said a set of, remember that curly bracket we read as the set of x such that x is greater than negative 5.5. So how do you put that? By the way, and also, and x belongs to or is z. Does anybody remember what are the z? What is the z? What kind of numbers fall into the z set of numbers? The z. Come on, champions. The z. Yes, it's integers. So I would definitely write, for example, I'm going to say x is going to be integers greater than negative 5.5. There's a type here. Anything that is greater than 5.5 is part of this z set, or the integers. All right. Second one, or B, says positive multiples of 10 use roster notation. I'm not sure why they did that to us, but that's not what I would choose. Yeah, because of the following. If you wanted to build roster, you should always start with the curly bracket. And then if you want a multiples of 10, well, do you want to multiply 10 times 1? That's a 10. That's a 20. That's 30. I am not going to keep going because that's going to keep going all the way through infinity. I'm not going to do that. So perhaps another notation here would probably be something like the set builder notation, right? Not roster. Roster is not the optimum one here in this case. But if that's what they ask, you could kind of fool the system and put dot, 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 etc., etc., etc. Okay, 3 dots usually, not more than 3. Okay, and so last one here, they wanted me to take this inequality and put that in a set builder notation. Remember that, such as. So I could say x such as x is less than negative 2, right? And it looks like we're talking about the number line. where I could just say it's less than -2. X is such that x is less than -2. And that should suffice in this example. Here's another one. It says rewrite each set in the indicated notation. Okay. Rewrite letter A problem like 2, 4, 6, 8 in words. Well, how do I write this in words? Well, perhaps you want to say even numbers between 2 and 8 and including 2 and 8. You also could say even numbers between 1 and 9. That's another way to do it. Yeah, even one between number 1 and 9. You could do that. The next one is x such that x is greater than 2, less than 8, and x belongs to or is part of the natural numbers. Okay, and they wanted me to use roster. That's wise. I could use roster for this because I could count. This is not too many to list here, right? Roster. I need to list every single one of them. So here we go. So I could say this is, if they're talking about, look at this. They're talking about natural numbers here. Like, what's natural numbers? Does anybody remember? Do we start natural numbers with 0? Do you start teaching your siblings, little siblings, counting starting with 0? And nobody does that. Come on. So anyways, so to have all this, you have to be greater than 2, which is 3, 4, 5, 6, 7. I can't touch 8 because it's less than 8. Okay, so leave that there and just curly bracket to close. That's it. That's how I use my raster rotation. Every single one of them. Set builder notation for the next one. Use set builder notation to I believe this is parentheses here. To describe this here. So you've got 99, including 99, all the way to infinity, and they want to see this in a set builder notation. Set builder notation, like the such as, remember? So this is x such that x is greater than or equal to, in this case, because you really have to equal to, or equal to, and I'm gonna put 99. It is that exactly, or equal to, and I will have to go back and do the 99. You could use that curly bracket x such as x is greater than 99. That's gonna take you all the way to infinity and beyond. Okay, looks good. Here's some other definition. A set is a collection of items called elements. We talked about that earlier. For example, here they're giving you the rule. The rule for 8 ball divides the set of billiard balls into 3 sets. If you've ever played pool, by the way. The first one is solids, 1 through 7. The second one is stripes, 9 through 15. And the 8th ball, obviously. Okay. A subset is a set whose element belongs to another set, just like the closet. Remember the closet that you have on your shelves? One, obviously, is a subset of the bigger closet. Empty set is a set that has nothing in it, no elements, and it's denoted by the phi symbol in Greek, or the 0 with the dash through it. That's the phi symbol. We talked about this one. We talked about these. Just for you to know that these sets in the numbers, they have their own labels, just like anything else that you could put in sets. You also have numbers put in sets. Same thing here again. Different symbols for sets. Okay. What are rational numbers? Rational numbers, again, are can be expressed as a quotient or ratio, division, fraction, of 2 integers, where the denominator is not a 0 and the decimal of the rational number either terminates or repeats. So that's what defines a rational number. You have to be terminating, meaning like the first example that we had in the warm-up, 2.5. It terminates, 2.5, and that's you stop. That's it. It's no more. Or it repeats, like 10 over 3, as we said. 3.33, and then you keep going. This is called rational numbers. Irrational numbers are not that. Okay? These are, for example, like square of 2. They cannot be expressed as a quotient of 2 integers. and it says the decimal forms do not terminate because they keep going. Just keep going. You try it square root of 2 in your calculator, and your friend tries it in their calculator. The calculators are different. They probably gonna terminate at some point, obviously, and I guarantee you they're probably not gonna be exactly the same down the road. Okay. Pretty close, you could approximate, but not exactly the same. So that's what we're saying. Two integers and decimals do not terminate or repeat. They do not repeat. You also could approximate these values as terminating, but in their nature they're not. You could approximate though. Just a recap of some ways to describe sets are by using words, roster notation, set builder notation, and then also in roster notation the elements are listed. You gotta have to list it in brackets. Okay, that's for that one. Here's an example of a roster notation. The set of billiard balls in numbers 1 through 15. You've got to list all of them. 1, 2, 3, all the way through 15, because you're taking roster. A set can be finite, like you know how many things are there, like for example, like the set of billiard balls numbers, or infinite, like the natural numbers. Natural numbers are 1, 2, 3, 4, all the way to infinity. These are infinite number of numbers. A finite set is defined, or finite, of the number of elements. An infinite has kind of, yeah, that's tough to, you cannot, for infinite, it's infinite. It's infinite. You can't have a number for that. There is something called the density property, which states that between two numbers, any two numbers is another real number. So any interval that includes more than 1 point contains indefinitely many points. What are they talking about here? Well, let me show you exactly what this means. If you are between two numbers, which actually I did earlier, but let's just go over this again since we're reviewing here. So let's say I am a 0 and then I is 1, and just for the sake of demonstration there's a 2 here. Okay, so what are the numbers between 1 and 2? There's a lot of them. According to the density property, there's a lot, because you could say, I have to make my line thinner, you could say this is I'm sorry, over here for example 1.1, and some of your friends might say, you know what, Armani, there's also more than just 1.1. So right before 1.1 I could have if I want right here 1.01. Another person would say, no, I could find a smaller value, 1.00001. So there is a lot of numbers, okay, and we call this the density property. It's so dense, there's a lot of numbers next to that little, between 1 and 2 there's a lot of numbers. Yeah, this is the lesson quiz, and this is gonna be an assignment that I'm gonna post on Schoology with details on exactly what to do. But just heads up, you will be needing to record an audio explaining to me how did you get these problems. Okay, so you do this. It's not going to be a quiz, it's going to be an assignment, and then you're going to do the problem. We got 5 problems total. You upload the notes and you give me a recording, an audio recording. If you want to use video, I'm okay with that as well, but we're going to start with audio. You're going to explain to me how did you do things. Okay, so on top of the notes you're going to also include the solution. Obviously I'm going to give you the solution here. That's not what you do when you watch the video. You do not look at the solution, you try things. Okay, when you watch the videos, please watch them thoroughly. An hour-long video doesn't take 5 minutes to finish. You need to spend time, you need to do it carefully, you need to look over the notes, you need to rewind. A couple of these slides that I showed today, you definitely need to rewind and rewatch again on pause. Okay, use interval notation to represent each one of these numbers. So you're going to use for number 3 and 4, how do you put that in interval? And we should have examples already done for you in the video presented earlier. And the last one here says rewrite this set as in words. Don't forget that n is referring to the natural numbers, and you just have to give me some words for this, okay? As we always do, we have 1 minute of hope with Armani towards the end. And today's word of encouragement and hope is we are not going to give up. Thank God for His grace, for the rain, a very shallow few drops a couple nights ago, and it was really helpful to clear up the air after these fires and wildfires and the heat wave that we're in. So we're thankful that we have a roof, and hopefully it's a little bit cool enough to be livable. And also we have food on the table. We're hopeful that we're going to go through these hardships and obstacles together, because we're in it together. We're going to, God is going to see us through this together. Okay, guys? I love you all. This should conclude our lecture today. Take care of yourselves. Bye-bye.